Assalamu alaikum. Today is the third lecture for the subject applied quantitative analysis and practices, and in this case, as we have discussed before, regarding contingency tables and the way how we represent these contingency tables. We were discussing about that, and going to the previous summary, let's have a brief workout on this previous lecture summary. Our last topic was related to the summary table and contingency table. And now, to be very specific, we discussed about what is the practical application of this subject, how the quantitative analysis need arose, and how we started measuring the intangible features of business research and business administration, like attitude and behaviors of the workforce, like organizational commitment, like leadership, like project management success factors. There are many arenas within the business area within an organization in which we need to measure these intangible areas. So we had to measure them, and we discussed about how the attempt was made to measure them, how these factors were converted into models to make some more logic, more sense, and once these models were introduced, then how we used to measure these logical models and how to convert this concept, this logic, into mathematics so that they can be measured accurately, and then based on those mathematical factors we could draw on concrete decisions. So the practical implication example was discussed briefly. We will be discussing about it in more detail with respect to time. Then we moved to the types of remaining probability and non-probability sampling. Going ahead with that, what were the issues related to populations, what are the advantages and disadvantages of these different type of sampling. Coming to the next issue which was discussed was the survey errors. Now this is one methodology which is very popular and very useful in business research, and that's why the survey methodology is discussed more often. Reason being so that its importance is very much elaborated, and you can see that in many areas these, I would say, surveys are frequently conducted, and yes, you can see in many newspapers, in many research journals, in many business magazines, various kind of surveys about various issues occurring in the business research are presented frequently, and that's why this methodology is of great importance. So what were the errors which we encounter while performing these surveys? It was discussed, and then as we are dealing with variables, because all these concepts theoretically are termed as concepts when they are discussed with logic, but once we are saying that we are trying to measure them, and we are trying to convert this whole concept into a mathematical form, then this same construct is termed as a variable. So that's why mostly in methodology part, the whole discussion is converted from concept phase to variable phase. So how would we organize these variables, once we have measured them on a certain scale, once we have measured the intensity of these concepts on a certain scale and then converted into variables, then how we are going to organize them. So coming to that, there are many ways to organize these variables, and that's why we use some very popular forms which we discussed in the form of summary table and contingency table. Summary table is one of the most common form, but nowadays contingency table is more frequently used. So now this was one of the diagram which we discussed before, and as we know, summary table is used to represent one categorical variable and contingency table is used to represent two categorical variables. Explaining that, we have just briefly described that what is contingency table used for. There are certain columns, there are rows, and in which we can elaborate the details of any two variables effectively in a contingency table. So now coming to the practical example of a contingency table, because you see the problem is that there are very standard forms of representing the data of any variable in front of the audience, but contingency tables sometimes, or even most of the times, can bring a very different picture in front of you. So here we are just seeing some past trends. This is certain data which has been collected. To be more specific, this is secondary data which has been collected from gazettes which are published to present various schools' result conducted by Board of Intermediate and Secondary Examination in Pakistan. So here you can see the past trends in matriculation results in government high schools in a certain district called Abbottabad. And here we can see that the trend is clearly evident. Presumably, you can see that the number of students which are appearing in the top you can say line graph, and in the below line graph we are portraying the number of students who are passing. So while looking at it, you can see that in between the difference presents the number of failures, and it just gives us a brief trend over past 10 or 11 years in terms of male students in government high school. Now coming to the next trend, just for your review and observation, this is the same kind of graph but of female students in government high schools in the same district from year 2000 to 2011, and again we are seeing a bit more smoother trend in number of students appearing and passing in the past few years. Now this is just one form of presenting the data which has been collected from secondary source, and we just give an overview of the previous trend in this case. However, this same data can be presented in a totally different way, and it can give us a totally different information. So we can have a look at that through another software which can be used for elaborating and can be used for making contingency tables. Though there are many softwares which can be used in this regard, like Microsoft Excel and other softwares, but we would be using more specialized software which is called SPSS, and then we would just use it to portray this same information in a kind of different way, so that you can come to know how the same information can give us some other vital information as well. So here on the screen you can see on SPSS software there are certain values which are entered in the software. Now SPSS software basic presentation is similar to Excel, where you can see many boxes, and in this case you can see rows and columns in which data is given. Now coming to the very basics in this case, we can easily see here that on the rows side there are certain numbers which are given, and in the form of 1, 2, 3, 4 and 5, and these are cases which are presented. Now on the columns there are certain variables which are written, and the first variable on the first column which you can see is gender. On the second column is the year, and third column is related to class. Fourth column is related to number of students who are appearing in the Board of Secondary and Board of Intermediate and Secondary Education exam. And then the fifth column represents the number of students who have passed. The next one, presenting percentage, gives us as a percentage of appearing and student passing there. So here in detail what you can see is that each row is representing the result of a separate government high school. So row number 1 represents the result of one government high school in Aptabad district, and by gender and year and class here you can easily see that there are numbers written. We will discuss it in detail what they represent. Here for now, to your knowledge, this is enough that the rows are representing separate government high schools, and we are only concerned with the number of students who are appearing and who are passing in the government high school in a certain year. Here under the year column you can see that the number 1 is written in the column in the various rows. This represents a certain year, and to give you a more elaborated form, I can convert it into a more meaningful data. So I click on view and click value labels. We will discuss it in detail why I have clicked that when we will be working on the situation, how to tackle the data and how to enter the data in SPSS. Now in this case you can see on the screen that more elaborative data is now being displayed in all these rows. You can clearly see, let's say in first government high school the gender is of male, it's a male government high school, and in year 2000 and the class is 10th, and we are seeing the number of students who have appeared in year 2000 and the number of students who have passed. Likewise the percentage is given here. Now here this is the standard data which we have collected in a given year for one government high school. Likewise, we have collected data of many government high schools, nearly all the government high school in Aptabad district, and you can see it here that in total 74 male government high school data has been entered here in the year 2000 related to class 10th. So the number of students appeared and passed in various government high schools are displayed here, and the numbers and the pass percentage is displayed. Now in this case, ahead of percentage, I have entered the area of that government high school. U here in case 1 represents that the school was in urban area, and whereas in the same area column R represents the rural area here. The next column ahead of area represents the percentage group. Now I have divided the percentages obtained by various government high schools into certain group, like the schools which have reported the pass percentage within 30 to 50% are placed in a group titled as 30-50%, which you can see. In case 1, the pass percentage obtained by male government high school was 31.2%, and it is then placed in the group of 30 to 50%. Now this group was generated by me in this software separately. The raw data which has been given to us is in the first 5 columns, and the rest of the calculation was carried out in this software. Now once we have made these percentage groups, we can now divide all these schools in these various groups, and now this information can be presented in the form of a table, so that we can elaborate this data in a more meaningful way. So here what can be seen is that we can just display this information in the form of a table, and we click on Analyze button here, and you can see that there is an option of table in this Analyze drop down menu. We click on Custom Tables here, and we are presented with a dialog box, and there's no need to go into more briefly. Just click on OK, and we are given here some empty columns and rows. So let's say we want to present the number of years in column, and so we drag the variable in the left column, which is year of passing, and we drag it to the column part here in the column part. So here you can see that automatically the number of years are being displayed, and the count means that it would count the number of cases which are under this column. So in the rows part here, we can drag the percentage group, the groups which we devised and in which we classified the results of each individual government high school, and we drag it here to rows. So once we do that, we have devised a contingency table which comprises of row of percentage groups, and in the column part we want to get displayed the year, the respective year in which the information is to be displayed. So we just click on OK, and as you can see, we are presented with a certain result. You see, the number of years are presented in the column part, and the percentage groups are presented in the rows, with 0 to 30% percentage group, which is reporting the number of schools which have reported result ranging from 0 to 30% in this group, and likewise in all the other groups which are listed below. So from here we can see that let's say in year 2000 there were 46 schools which represented result which was within the group percentage of 0 to 30%, and likewise in year 2001 this number dramatically decreased from 46 to 24, and then in the next year it decreased from 24 to 8. But in 2003 there was a certain jump, and the number increased from 8 to 57. That means that in year 2003 overall the progress of the government high school in terms of pass percentage declined. So basically we at first as you could see, as we have seen before, we just displayed the graph of overall result of number of students who have appeared and number of students who have passed in government high school. Now that data was derived from all these individual entries which were made under each government high school in the column of number of students appeared and number of students passed. And we just added them to calculate the number of students appeared in the year 2000 and number of students who have passed in the next year. However, now just displaying the graph in a trend-like position is one thing, but then we can use that same data which was initially fed in SPSS, we can convert it into percentage groups, and we converted it into its display in a contingency table. And then when we displayed it in a contingency table here, it gave us a totally different information from a totally new different dimension. So here we can see that overall there was let's say in the group of 90 to 100% result reporting schools, it was 6 in year 2000. It increased to 13 in year 2001. In 2002 it increased to 24. However, in 2003 it drastically decreased and the performance wasn't very good up till, I would say, up till of year 2005. So basically the display of data from a totally different perspective in a contingency table can give us some very vital information which general tools like displaying of graphs or bar graphs or pie chart may not give us that much information. So contingency table or the display of data in such kind of tables gives us some very vital information, and that can be of great importance, I can say. So coming back to the chart here, you can see that this was the initial result which was shown in this graph, and again here you can see that these past trends, they give us very simplistic information. However, a more detailed information in the form of a contingency table, which we discussed before, gave us some additional vital information which was hidden behind these numbers. So these simple tools most of the times can give us some vital information which can be of great use to us in coming time. So coming to the next I would say tool which is used is called an array. Again, it's also termed as ordered array, and it's generally a sequence of data ranging from smallest value to highest value, and we are just seeing an example of that. Let's say we want to have a survey of age of college students which ranges from 16 to 42 in terms of day students, and from 18 to 45 in terms of 45 in terms of night students here. So it gives us a brief distribution of data. Then again, it can show us some outliers, some unusual values which can be of problem for us in future. So now basically an array is just a chart of the values which have been produced in ascending or descending order, and from that specific chart you can very well see what's the values, what are the broad spectrum of values of your data, and which values are usable and which values are not usable. So coming to the next important tool, which is more important than all of the others, is called frequency distribution. Frequency distribution is a summary table, and in which the data is arranged into ordered classes. Now, the frequency distribution comprises of class groupings, and then there are certain widths of these class groupings, and we have to determine the boundaries of each class. Now, the number of classes depends upon the number of values within that data, and the higher is the number of values, then the greater would be the classes. And again, there is a certain limit that there shouldn't be less than 5 and shouldn't be more than 15 classes, and how we have to determine the width of each class. But again, it depends upon the number of classes which you would require. So that's why, in order to determine the width of class interval, which is the period between these values, you can divide the range, which is the difference between highest value and lowest value, with the number of class groupings. You can have that easily. So just going through an example, here we have got a range of values which basically represent the, I would say, temperature, different temperatures recorded in different number of days. And first what we have done is that we have sorted this raw data in ascending order, or we can also say in kind of an ordered array. So in this case, once we have sorted it out, we can see the whole range, the whole distribution, and then again, to some extent, we can also identify that what are the unusual, abnormal, high or low values. Now, in order to find the range, we just subtract the lowest value with the highest value in the data, which in this case is 58 minus 12, which is 46. Now, as we have seen that minimum number of classes should be 5, so let's say number of classes here desired are 5, and in this case we have to compute the width or also class intervals. So in order to do that, what you have to do is simply divide the range with the number of desired classes, and it can give you the class interval. And again, in this case, you can see the class interval has been rounded up, and mostly this figure is rounded up for the ease of analysis. Now, in order to define the limits, as we have defined the class interval, then we can easily say that for class 1, the limit starts from 10 to 20, and then likewise from class 2, in class 2 it is from 20 to 30, and from ahead onwards, you can see in class 5 up to class 5, the whole thing ends up from 50 to 60. So by computing these class midpoints, which are basically the midpoints or mid values of these class intervals, we have got basically 5 in midpoints in number. So again, once we have computed these midpoints, we can then count the observations and then assign them to classes, which is evident in the next slide. Here you can see that in ordered array in the top the data is displayed, and now in the left side column we can see that the class ranging from 10 to 20 has got a midpoint of 15, which is the standard midpoint between these two values. In principle, the number of values which are ranging in between these two or within this class interval are 3, which are 12, 13 and 17. So similarly, in the next class, which is ranging from 20 to 30, the frequency or the number of values which range in between these are 6, so which is the frequency basically. So similarly, we have got the frequency of 5 in between 30 and 40. We have got a frequency of 4 between 40 and 50, and a frequency of 2 between 50 and 60. So in total, there are 20 values which are displayed under various class intervals. Now, this same data which was displayed in the form of frequency is defined here in terms of relative frequency or percentage. In relative frequency, the only difference is that we calculate the percentage of the individual frequency in terms of the total frequency calculated. So from here you can see the relative frequency without converting it into percentage is 0.15 for first class interval, for second class interval it's 0.30, for third it's 0.25, and then similarly 0.20 and 0.1. Now the same thing which is converted into percentage by multiplying it into 100 gives us the relative percentage of values lying between these various class intervals. So a total of 100% is then computed at the end in order to know that the values have been distributed correctly. So now coming to the next one, we are coming to the concept of cumulative frequency or cumulative percentage. And in this case, again, the cumulative frequency gives us the cumulation of all the frequencies. Here you can see the first one is 3, but then for second class we added up the 3 with 6 to make it 9. Then in third class we have added the number 5 with 9 to make it 14. So this is basically the cumulation of frequencies stepwise for each class interval as shown here. So similarly, likewise, we added up 4 with 14 to make the cumulative frequency of 18 in the second last class interval. Cumulative percentage follows the same concept which has been followed in the cumulative frequency. The only difference is that you have to calculate the cumulative percentage from the percentage part column which has been displayed here. So here you can see the first is 15%. In second class, we have added 30% with 15 to make it 45, and likewise, we have calculated the rest of the values to make it the total 100%. So now, the question is why we should use a frequency distribution. Basically, this is the summarization of data, an effective summarization of data, and it gives us a faint idea of how the data is distributed in the whole set of values which have been given to us. And we can have a quick interpretation of the data, and then again whether the data or the values are concentrated at one point or they are far from the central point. So basically it does gives us brief, I would say, introduction of the various characteristics of data, how they are distributed, how they are spread, and it gives us a very, I would say, in a very short time we can determine that what nature of data we are dealing with. Then again, there are some tips regarding that the distribution of data again depends upon the class boundaries or class limits which we have discussed before. So it depends. There are different class boundaries for different kinds of data, and for smaller data sets and for larger data sets there would be different class boundaries which would show some different characteristics. Now then again, data concentration would vary from data to data, and again you see as the size of the data set increases, then the alteration impact has also an impact. So in this case it is also reduced. And then if you want to compare two frequency distributions, then it is wiser to compare the relative frequency distribution, because original frequency cannot be used to compare any two frequency distributions derived from two different or more than two different data sets. So that's why cumulative frequency, or I would say relative frequency or percentage distribution, is more effective while comparing different kinds of data. So now coming to the next one, there are different forms for graphical display as well, because previously what we have discussed is how to display this data in the form of a table and how we can effectively represent this thing in the table in this case. So once we have gone through that, this is vital that we also check out that whether how we can present this data in graphical form in a more effective manner. So in this case we can see that summary table for one table can be represented in the form of a bar chart or a pie chart as well. There are many other forms of charts, but the main forms which are most commonly used are bar chart and pie chart. Likewise, contingency table for two variables can also be portrayed in the form of a side-by-side bar chart in which the same information is presented in the form of two bars or for showing two variables of the same type. So then this is just one example of how a bar chart has been presented. And you see the summary table can be seen on the left hand side, but the same summary table and the values presented to it have been converted into percentage, and that same percentage is then portrayed in the form of chart, which is also called bar chart, and it is presented here. So you see, basically these graphs are presented to enable the audience to compare vaguely the values in front of them, to compare the different entities. In this case, bar chart may not portray some very accurate figures, because basically this is just for comparing the values in one glance. So if you want to have a more detailed outlook about how to compare the exact values or the micro level data, then you should better convert this bar chart into a summary table, which would give us more accurate data. So the next is the pie chart, and in pie chart the presentation of the same kind of data has been displayed in the form of a pie, in which the various slices represent the various percentages, which you can see, of various factors. So same summary table has been displayed in the form of a pie chart, and the slices represent the various percentage. Again, these kind of tools are effective in comparing the various options, and nothing more than that. Then here we have got a contingency table, and in this case you can see this table presents the same information which we have discussed before, in which two variables like the amount and the errors are presented in columns and rows. And you can see that in columns and in rows the various values have been presented in bar chart. So in error in y-axis, the all small, medium and large amount has been presented in one cohort, and this gives us a brief description, and we can compare them more effectively. So side-by-side bar chart is effective, specifically when we are dealing with 2 or more variables, and the bar chart is effective. In fact, a stacked bar chart is effective in displaying such kind of data. Coming to the numerical data, we have got various tools to display such kind of information, and in this case first is the ordered array, under which comes the stem and leaf display here. Then similarly there is frequency distributions and cumulative distribution, under which the other tools come like histogram, polygon and OGIF. Among these, histogram is more commonly used to portray data, but we will discuss all the options here. So here stem and leaf display under the previous type which we have discussed is portrayed, and here you can say this is one of the simple methods of displaying the data, and there are 2 main ingredients in this case. One is the stem and the other is the leaf. We will see it by example. You can see here that we have displayed the data in left box, in which age of surveyed college student is given among the day students and night students as well. Now the same data has been distributed into 2 factors. One is stem and the other is leaf. So here in day students you can see that the numbers given under day student table have been distributed in terms of those numbers having the 1 digit at first. So the number 1 digit coming in the numbers here is 16, 17, 17, 18, 18, 18, 19, 19. So basically these are in general 8 values in which the number 1 comes in the first place. So the first place is termed as the stem, which is displayed in the stem part in day students, and the leaf is the numbers which are appearing in the second place of the same number. So here the leaf 6, 7, 7, 8, 8, 8, 9, 9 basically represents the numbers which are coming at the second place of those numbers in which the first place the number 1 is present. So basically we just separate the second number from the first number, and the first number here just gives us the value of stem, and the rest of the second values are just written consecutively here in the leaf part. So similarly in the values in which the stem is 2, it is the number comprising of 20, 20, 21, 22, 22, 25 and 27. So the common first digit is 2, and that is also called the stem, and the rest of the values are written in the leaf part. So likewise we have distributed all the other values in stem and leaf for day student and night student as well, and displayed them in this form. So now coming to the next topic, which is related to the histogram. Now histogram is more frequently used in business applications, and basically we have just displayed the frequency distribution which we have discussed before in the form of a bar chart. And in this case, however, these bars don't have any gaps, and you see the class boundaries or the midpoints are presented in horizontal axis, and the relative frequency is shown in vertical axis. So basically the height of these bars shows us the frequency which is written. So we can see it here. So here in this slide you can see that the class here displays the various options, the class intervals, and the frequency is displayed here as we have discussed before. Now the relative frequency is also given in the chart, which is calculated by dividing this frequency, the individual frequency, let's say in this case is 3, by 20, which is the total frequency. So once we have calculated all the individual relative frequencies, we can add them up to get the final value of 1, and the relative percentage then can easily be calculated by multiplying these relative frequency with 100. So the percentage is given here. Now once this whole chart is given, this can be displayed in the form of a diagram, which is also termed as histogram. Now the midpoints are displayed on the x-axis as we have discussed in the previous slide, and here you can see in x-axis the midpoints is given as 5, 15, 25, 35, 45 and 55. Now the frequency, which is, let's say in case of first class, is 3. So the first bar which is going upward is frequency is displayed in terms of y-axis. So 3 frequency is displayed in terms of first bar. Likewise the second frequency is 6, so you can compare the value of frequency of 6 in terms of y-axis, which is evident here. So histogram gives us displays the frequency values of these class intervals in the form of a graph, in the form of a bar chart, a vertical bar chart. And this gives us the distribution of data more effectively, instead that we just see the values on a table. So that's why histogram is most commonly used while displaying some vital information of business statistics. Then the next tool which is used, though not commonly used practically, is called polygon. A percentage polygon is then again made by having the midpoint of each class, and then we have to connect the sequence of these midpoints in with their respective class percentages. So then the cumulative value gives us the variable along x-axis and the percentages with y-axis. Basically it's useful when we are comparing two or more groups. Now here this is just one example of two group of values which have been given in terms of city variable and suburban variables. Now the metal cost has been given, and we have just displayed the midpoint values, and we just plotted the percentage above these, and both kind of data's midpoints have been plotted, and then they have been interconnected, so that overall situation and the trend of the data submitted for both the variables can be effectively compared. That's why it's called a frequency polygon. This is another example of a percentage polygon. We have just converted the value in percentage. The variables which have been under study here in this case are converted to percentage, which are growth funds and value funds. Again, the midpoint values have been plotted for both the groups, and the relative graphs have been plotted so that we can compare the data trends for both the values in this case. Then coming to the next slide, then the most important variable again which should be considered are scatter plot and time series plot. They are more important while we are trying to access the association of variables, or to find out that how the data has moved from time to time, when specifically we are trying to see the time series plotting. Scatter plots basically are paired observations which have been taken from perspective of two variables. Again, one variable is plotted on x-axis and the other on y-axis, and then these values are examined if there is any kind of possible relationship. The example of this can be seen here, in which we can see that we have got two values like volume per day and cost per day in this case. So volume per day gives us the certain values which have been plotted in x-axis, and cost per day values are plotted in y-axis. So basically these values do give us a certain trend, that they have some kind of relationship with each other. The more clustered these values are with each other, that means that these values do have some kind of relationship. And again, it also depends upon the pattern, whether these patterns are linear or whether they are quadratic in nature. So these patterns are curvilinear pattern. So all these patterns do give us a notion that there can be some kind of relationship. Basically, this tool is used to have an initial idea of whether any kind of relationship exists between two values. You can just take the example that, let's say I have taken the response about the leadership of a company from certain respondents, and I have displayed them here in the left column, and as compared to that I have collected the data of individual employees' performance in the right column. So when I plot both of them, I would try to see whether there has been any kind of relationship initially in between these two values. So the initial scatter plot in the form of a graph gives us a very faint idea that whether there may be some relationship in between these two variables, and based on that we can decide whether we should go ahead with further analysis in order to know whether some concrete evidence is there in terms of relationship between these two values. So now the time series plotting is another pattern, but the difference between this and the scatter plot is the time series plot is basically used to study the values occurring over time, so over a specific period of time. So you can easily see that numerical values can be portrayed in vertical axis and time period can be shown in horizontal axis in this case. Again, there are examples which can be portrayed for that. We have seen that in left side it is the year given, and on right side number of franchises are stated. So we have just plotted the year in x-axis, and on y-axis we have just plotted the number of franchises. So when we just plot these values over a certain time period, they just give us a certain trend of data over the certain period of time. So time series plot is very effective, specifically for those studies in which financial data pattern is being studied over a period of time, and in that time series plot is very effective in this case. So time series plotting is also used other than financial data. You can see the same example which we have discussed before for displaying the importance of contingency table can be quoted here as well. Here, as we have discussed before, that we just studied the pass percentage, or the number of students who were appearing and passing over the past few years in board results, and this is another example of time series plotting. So you see, again, it's not necessary that time series plotting can give you vital information regarding all the aspects, and we may use other tools like contingency table and summary tables to in order to know more additional information, but it does give us a brief trend or a certain period of time. So here you can see the trend over the previous years, and this does give us some very vital information. Then again, under the contingency table in categorical variable display, multidimensional contingency tables are also used, and we can use 3 or more categorical variables in this case. And this is just one example here that we are just comparing growth funds and value funds, and in this case the grand total is given in row. However, in this case the risk factor, which is termed under 3 categories termed as low, average and high, is displayed in columns. So basically more than 2 variables are being used in order to compare them in contingency table here. So basically different kind of variables can be used in this case. Then again, in 2 variables case you have seen here in this slide, and multidimensional is shown where we are showing subtypes of growth funds and subtypes of value funds here, which are termed as large, mid cap and small, and similarly in case of value funds. So once we have portrayed them in contingency table, these multidimensional contingency table can also be used to portray more effective data in this case. So again, there are certain guidelines for obscuration of data. First is that you should avoid chart junk. By chart junk, I mean that you should not include meaningless information in your data site. And again, in the next part, you should display the simplest possible visualization, because the more simple is the data, the more easier it is for the audience to understand the information. Coming to the next one is that you should include a title in this case, and it should be given there in order to give the audience an idea of what the whole thing is about. You should label all the axes, which is the vital detail, and the scale should be included here. And again, it should be taken care of that the vertical scale and the horizontal scale should start from 0, and a constant scale should be used in this case. So in this lecture we discussed about practical implications of contingency table. We just displayed that how factual data is presented in summary form, in a graphical form, but the same data, if presented in a contingency table, can give us some more vital information. We discussed about the ordered array, the frequency distribution, histogram, bar chart and pie chart, and these tools implication, how the data is presented there and how it can be displayed. Likewise, stem and leaf display and polygon chart was discussed. The 2 vital factors which are used for displaying and initially observing data, whether there is a relationship between them, is scatter plotting and time series plot, which is very vital in order to know whether there is some specific relationship existing. And similarly, we discussed the various guidelines which are necessary for obscuring the data, and while what should be followed in this case in order to effectively present the data in front of a certain audience. This is the end of this lecture. Thank you so much. Allah Hafiz.